Hello everyone, today I will tell you about the most active and unusual metal on Earth, cesium. Cesium is an active alkali metal, which is located near the bottom of the periodic table of chemical elements. Only francium can be more active than cesium, but that metal is radioactive and only an insignificant amount of it was obtained in its pure form to do any experiments with it. Because of its high activity, metallic cesium is being stored in special ampoules under inert atmosphere of either argon or hydrogen. Appearance-wise, cesium has a yellowish tint, like gold, but the price for cesium is still higher than gold. Due to the extremely small sales market and its highest activity, price of cesium can reach over 100 euros per gram. The vial, which you see on the screen, is 50 grams of cesium. Just imagine its cost. Cesium is unusual in that it has a very low melting point, only 29 degrees Celsius. If you take the vial of cesium in hand, you can see how quickly the metal begins to melt. Even while cesium is still in the vial, we can already conduct experiments with it. If you leave the liquid cesium in a vial for some time, it partially hardens, forming very beautiful crystals of pure cesium. Also, due to cesium's solidification, its volume is being significantly reduced, as can be clearly seen with the funnel formed from solidified cesium in the ampoule. Now, let's proceed to the most interesting part, conducting experiments with cesium. Firstly, to get the cesium out of the vial, I decided to melt it in the vial, and then pour out the liquid cesium in kerosene. However, something went wrong during that part. The liquid cesium instantly ignited in air, burning everything around it. That happened most likely due to the fact that the cesium in the vial was liquid. A water hammer happened, and the top of the vial broke off, pouring cesium onto the table. You can see what happened next. The table is now out of use, but that's okay. We still have more tables. For further experiments, we had to buy another vial of cesium. Now I decided to do things differently, breaking the end of the ampoule with a solid cesium and then heating kerosene. This all turned out well. Gradually the liquid cesium began to flow from the vial into the kerosene, after which it immediately lost its golden shine and got covered with a layer of oxides and peroxides, due to the impurity of water and oxygen in kerosene. We have decided to destroy the vial with the remnants of liquid cesium by throwing it onto the wet wall. After solidifying, the cesium can be easily cut, even with a spatula, and it is not just the most active but also the softest metal in the world, that resembles margarine for its softness. For the first time on YouTube, you can now observe cesium as being cut. First, I took a piece of cesium and put it on a piece of wood. Cesium melts from the oxidation reaction of oxygen in the air, and then self-ignites with a beautiful magenta flame due to cesium ions. Cesium also behaves similarly on the napkin. Furthermore, by analogy with rubidium, I decided to conduct the reaction of cesium with sand, igniting cesium on sand. Similarly to rubidium, cesium reacts with the silica, which the sand consists of, very calmly and forms a beautiful shiny surface, and also an amorphous silicon. Next I decided to learn how cesium reacts with manganese sulfate. The response wasn't very rough, but it is better that it was with sand, when it's formed a metal manganese. The coolest reaction by far was cesium with sulfur, when we trap the pieces of cesium in molten sulfur. In that reaction, the two elements formed cesium sulfide. Also, we decided to fuse copper with cesium. With that, an unusual compound was formed, the intermetallic compound of copper and cesium, which eventually decayed due to cesium's oxidation by atmospheric oxygen. If you throw a piece of cesium into the glass filled with ethanol, cesium will self-ignite, even in alcohol, coloring the flame of alcohol with beautiful purple, due to cesium ions. Lastly, we decided to throw about 20 grams of cesium in a container filled with the ice water. As you can see, cesium explodes at the first contact with water, although not so strongly as it's sometimes portrayed in other videos. Cesium has a variety of applications. These days, metallic cesium is used in the most accurate atomic clocks, the error of which is only a second per 100 million years. Also, cesium is used in the new engines for orbital satellites. Until about the early 2000s, before the rise of microelectronics, cesium has been widely used in photocells and motion sensors. However, after the market has been flooded with cheap transistor analogies, the need for such a large number of manufacturing metallic cesium disappeared, and the price of cesium has since risen sharply. And lastly, I would like to thank the company Mel Science, without whom the production of this video would have been impossible. This cesium was worth a lot of money, not to mention the burning of the table. It was all done for science, and so that you, my channel viewer, could learn a lot about this amazing metal, cesium. Like the video if you enjoyed it, subscribe to my channel, and also visit the website site of our sponsor, Mel Science. Thank you for watching.